All right, so we are on number 11. So let's look for a GCF. They don't have any greatest common factor, any factors in common. We do have a perfect square here, x squared, but 7 is not a perfect square, 12 is not. It really doesn't fit either of these patterns. Also, this has 3 terms, while this has 2 terms. There's a binomial, 2 terms, and 2 terms. So we can't follow this pattern because the pattern doesn't really exist. We don't have a perfect square minus a perfect square. We have 3 terms here. So how do we do this one? We'll think to yesterday. If there's 3 terms and no GCF, you kind of want to set up your parentheses like this. And think about what multiplies to 1x squared would be 1 times 1. And think of your combinations that multiply to 12. We have 1 and 12, 2 and 6, 3 and 4. So let's try one of those combinations. What do you think would be smart to try first? I'm trying to get a -7 out of these, so let's try 3 and 4. And when I draw my outermost arrow, 1x times 4 is 4x. The innermost arrow is 3x. 3x and 4x could get a -7 if they're both negative. And then you want to remember to check the last term again. Do I get a positive 12? -3 times -4. Yep, that gives me a positive 12. So my answer is x minus 3 times x minus 4. So it doesn't follow the pattern that we've been practicing, but it's still factorable. It's just one like yesterday, not a new one with a pattern for today. Number 12. Look for a GCF. They have a 64 in common. If you tried, so let's talk about some large numbers. Let's say you tried to take out a -2. Divide by -2, I get 32. Divide by -2, I get -256. But you'll notice 32 and 256 have a number in common. So this was not the greatest common factor. You could just watch. For right now, I'm going to try another one. Let's say you thought they both have a 4 in common. If I divide by 4, 64 divided by 4 is 16. 512 divided by 4 is 128. And look at what is left. You get 16 and 128. Do those have anything in common? They have at least a 2 in common, maybe larger. So again, this is not the greatest factor to take out if what's left still has a common factor. So that's kind of how you know if you've got the largest factor or not. So don't take those out. Take the largest one you can find, which is actually 64. And we want to make sure our leading coefficient is not negative, so I'm taking out a negative so that I get x cubed. Divide 512 by -64, and I get -8y cubed. I know this is the greatest common factor because this leaves me with a 1 coefficient and an 8, and those have nothing in common. So now that I have my GCF, do I have a perfect square, perfect cube? Do I have a perfect square, perfect cube? I have a perfect cube. What's being cubed here is x. So that's like my a value. What's being cubed here to get 8 is 2. And what's being cubed to get y cubed is y. So this is my a value. This is my b value. I'm following this pattern here. So I take my a. Notice there's a minus here. That's how I know it's this pattern, perfect cube minus perfect cube. So I will follow this pattern. The 64 will just stay there. And then I'm going to do x minus 2y, keep the same sign. And then a squared, so this squared is x squared. Opposite sign of what we started with a minus, and now it's plus. A times b, so what do I get when I multiply an x times a 2y? 2 times x times y. It could be written as 2yx, either way. And then finally it says up here b squared. This is b. So if I square that, I get 4y squared. That is my answer. Those are my factors. If I were to distribute that out, which would take a while, I wouldn't expect you to do that, you would get this original polynomial. Number 13. You'll notice it's not in standard form. It's a good idea to get it in standard form before we start factoring, so it kind of looks like what we've been doing lately. So let's write the negative x cubed first and the 125 last. Then we don't want a negative coefficient, so from there I would factor out a negative. Divide by negative, I get x cubed. Divide by negative, I get negative 125. Now look for a pattern. This is a perfect cube. X is being cubed. This is a perfect cube. Here's my perfect cube table. That's 5 being cubed. I know to follow this pattern because it's a perfect cube minus a perfect cube. This was x cubed minus 5 cubed. So this again is my a value, and the 5 is my b value. That's how I figure out this, my answer, or my factors. I take a minus b. So x minus 5, and then I do a squared, so this term squared, which is x squared. Opposite sign, so now I need a plus sign. A times b, 5 times x, plus b squared. And that is my answer. Okay, last one, number 14. Again, always check for a GCF. If you find one, try to see if what's left has any common factors, see if you can get a larger one. In this case, they have no common factors, but we are going to take out a negative, so our leading coefficient is not negative 512. So divide by a negative, 512x cubed plus 343 x squared. Okay, so what can we do here? Is this a perfect cube? Let's check. 512, yep. So this number came from 8 times 8 times 8, or 8 cubed, and x cubed comes from x times x times x. That is my a value. And to get this term, 343, that was 7 cubed, so 7 is my b value. Which pattern are we using? These are perfect cubes, so it's going to be one of these two. And it's a perfect cube plus a perfect cube. So we'll have to use this pattern because this is the one that is a perfect cube plus a perfect cube. We already know our a and our b, so we're ready to just plug them right in here to get our final answer, or our factors. So it's going to be a plus b, so here's a and here's b, so 8x plus 7 8x plus 7, and then I need to do a squared, so 8x squared is 64x squared minus a times b, so multiply them together. 8 times 7 is 56x, and finally b squared, or 7 squared, which is 49. Okay, so that is how we factor. Don't forget, they don't all follow these patterns. There might be one that follows the pattern from yesterday, which is just not really a pattern, just some combinations. Go ahead and use your notes when you're doing your homework today, and let me know what questions you have.